Okay, here's our first big problem for section 5.6, where we're asked to find all the real zeros of a polynomial function that is not factored. It's up to us to figure out what they are. We can't go straight to some kind of formula like a quadratic formula. So we have to start with determining with our steps, use the steps from the previous page to determine the maximum number. So the max number of real zeros is what? It's 3. The highest power on x. That's it. That's the maximum number. Okay? All right, so the next thing we're supposed to determine is how many positives and how many negatives using Descartes' rule of signs. So positive real zeros, how many do we expect? Well, that's positive to positive, no change. Positive to negative, there's a change. Negative to negative, no change. So there's definitely 1. And I can't subtract an even integer from that, so there's definitely 1. To find the negatives, I need to substitute in negative x for x. And what do we get? We get negative 3x cubed minus 8x plus 7x minus 12. Counting sign changes now. Negative to negative, no change. Negative to positive, there's a change. Positive to negative, there's a change. So for negative real zeros, I have 2, or I could have 2 imaginaries and then have none that were negative. Okay, that was step 2. Step 3 said if the polynomial has integer coefficients, yes we do, 3, 8, negative 7, negative 12, then use the rational zeros theorem to identify the rational numbers that could potentially be zeros. So I need to find all the factors of negative 12, that's p. Oh, and actually it reminds us, we just did that. This was the exact function we did in example 3, so I can go ahead and do what p over q is because we already had that list. P over Q was plus or minus 1, 2, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. So all rational zeros of this function are in that list. Okay, then it says we're going to use synthetic division. Now, we do just have to start with a number from that list and use our synthetic division. I know I only have 1 positive, I have 2 negatives, but I might not have any. So, you could start, that one of these positive numbers could be on the list if it's rational. So it's just wherever you want to start. Right? So we could start with positive 1 and see if that works. Remember our synthetic division, however you set that up. The coefficients are 3, 8, negative 7, negative 12. Recall you bring the first number down, multiply, add, multiply, add, multiply, and add. My remainder is not 0, so 1 is not a real 0, and I have not found a factor. I might want to try a negative 1. These are easy to divide by, so sometimes they're a nice place to start. Bring down the first one. Negative 1 times 3 is negative 3. Add, multiply, add, multiply, add. And look, I have found that negative 1 is a real 0. It's on my list, and it's one of my negatives. That means I definitely have another negative, because there's no option to just have 1 negative. I have found 1, so there's definitely 2 negatives. And these are the coefficients of the depressed equation. The coefficients of the depressed equation that they referred to. And of course, that's our remainder. So I know that negative 1 is a real 0. I know that x minus negative 1, or x plus 1, is a factor. That's what that all means, right? Once we found a real zero, we know we have a factor. Okay, so it says, now continue doing synthetic division with your depressed equation. So here's what we mean by the depressed equation. Those are the coefficients, but the equation looks like this. We drop one power. We've divided, so now it's 3x squared plus 5x minus 12. That's what's left. Now, it said, if you can, use other techniques. We can keep using synthetic division, but I could also say, hey, that's a trinomial. Let me set it equal to 0, and maybe I can find the factors that way. And so you could use the quadratic formula, or you could factor it. Try factoring. I think this one might factor. I want to give it a shot. Let's see. 9 and 4. Yeah. So if I make that positive and that negative, so 3x squared, there's positive 9 minus 4 would give me the 5, and negative 4 times positive 3, the 12. So 3x minus 4 equals 0, 3x equals 4, and x equals 4 thirds. Notice that's on my list, and it's positive. X plus 3 equals 0, x equals negative 3. There's the other negative. We found negative 1, negative 3, positive 4 thirds. They all ended up being rational, and they're all on our list. So you don't have to continue doing synthetic division. Once you get to a point, sometimes you're able to do something like this. Could I have? Yes. Let me show you what I would have done. Say I get to this point, and now I want to continue doing synthetic division, and say I want to try negative 3. Well, I'm not going to put 3, 8, negative 7, and negative 12. I have reduced it now to 3, 5, and negative 12. So I'm using the depressed equation, and let's try negative 3 as a real 0 and see what happens. Bring down the 3. Negative 3 times 3 would be negative 9. Add negative 4. Negative 3 times negative 4 is 12. And notice we get a remainder of 0. And now we have a new depressed equation. This would be 3x minus 4. And so you could set that equal to 0 and solve, and look what happens. We get that 4 thirds. So you could continue with synthetic division. Of course, I knew to choose negative 3 because I already knew that it worked. But I'm just showing you that it does work with synthetic division. But at any point, if you can get it another way, other than trial and check with synthetic division, that's what you ought to do. Just use some other method. If you have 4 terms that you can factor by grouping, do that. 3 terms that you can factor, or put in the quadratic formula, right? We could have plugged that into the quadratic formula. So we have found the real zeros, and there's no fancy way to say that, to list them, other than that we had negative 1, we had negative 3, and we had 4 thirds.